Good morning, everyone. We are now dealing with applications of integration, calculating volume. So, we have been dealing with area, so you should be familiar with sketching your graphs from the section of area. Now we're going to be dealing with volume. Let's have a look at the first question. Right, so it's best explained using an example. The area enclosed by the straight line y is equal to 5x, the x-axis, and the line x is equal to 2 rotates about the x-axis. Okay, so we are rotating about the x-axis. Calculate the volume of the cone obtained in this way. So how do we sketch the graph y is equal to 5x? What do we have? We have y is equal to mx. So this is a straight line. Okay. Now, for this type of straight line, you could have m greater than 0, that means positive, or m less than 0, that will be negative. So if you have the equation in the form y is equal to mx, then here you check your gradient. If your gradient could be either greater than 0, that means positive, or your gradient could be less than 0, which is negative. Now, what's easy about sketching this graph is it has to pass through the origin, which is 0, 0. So if we have a situation like this, then if your gradient is greater than 0, then your graph will be increasing. If it's less than 0, decreasing. So basically this is an increasing function, and this is a decreasing function. Function because it satisfies the vertical line test. For one input, there's one output. Right, so what you need to remember is basically if the gradient is positive, it's increasing, gradient is negative, decreasing. You can use a table if you want to, it's your choice. So let's do this graph. Let's sketch it properly. Let's take some values here. X, y is equal to 5x. So you can use a table. You can start with 0. When x is equal to 0, y is equal to 5 times 0, which is 0. When x is equal to 1, y is equal to 5 times 1, which is 5. When x is equal to 2, y is equal to 5 times 2, which is 10. When x is equal to minus 1, 5 times minus 1 is minus 5. When x is equal to minus 2, 5 times minus 2 is minus 10. These are a few points so you have an idea of the shape of the graph. So you know now we are dealing with y is equal to 5x. So here your gradient is positive. So without any table, you should know exactly how to look. So here is my graph y is equal to 5x. Right. Now if you want to show these values, you can. Maybe there's 1 here, 2 there, 3. This will be minus 1, minus 2. When x is equal to 1, you could have 1, 2, 3. It carries on and on. It's just a rough sketch. Now, you got your straight line. The next thing is, okay, the area enclosed by the straight line y is equal to 5x. The x-axis must be familiar with that area. We need to sketch the line x is equal to 2. So there is your vertical line. Okay. So remember, x equal to a number, a constant, is a vertical line. If I had y equal to a number, it will be a horizontal line. Now, the area bounded by the straight line, y is equal to 5x. The other straight line, x is equal to 2, and the x-axis. Okay, so the area that we're talking about is this area here. That is the area. Now, what does this question say? Calculate the volume of the cone obtained in this way when this area rotates about the x-axis. Now, how will this look? So, what's going to happen here is, if I draw a line coming down there, okay, just showing you how the area, how this volume, how the area when it rotates, how it will look. So here is this area. We are taking this area and rotating it around the x-axis. So when you rotate it around the x-axis, this is what's going to happen. Here is your volume, there is the cone. So this is what we're looking at. There, and there. Right, so there is the cone that is obtained. Now, what you need to take note of is that this here is the x-axis. We are going around the x-axis. So, here's your x-axis, that means you're going up and down. You're going up and down. So, therefore, the radius when you're going up, the distance from the center to the circumference, this is your circumference. So this is your radius. Okay. So the radius is the distance measured from the center of the circle to any point on the circumference. So your R, there's your radius. Now when you are measuring going up, you are measuring a value in terms of y. Basically you're measuring a y value. So if you're measuring up, it's a y value, your radius is in terms of y. Okay. Now, that was talking about the radius. Let's get back to the area only. Now that you understand what is going to be come of this area after you rotate, let's go back to the area. Now in N5, there is only one method that we're going to be using. It's called the disk method. Right, so in N5, we use the disk method. In N6, we use the disk method and the shell method, which you can watch some of my videos on volume if you're interested in understanding both methods. But in N5, it's simple. We only use the disk method. So what is the formula for the disk method? Volume is equal to area of base multiplied by the perpendicular height. So this is the only formula that we are using in N5. It's always area of base times perpendicular height for the disk method. Now, we are talking about area of the base. So basically the base is the bottom. This is the base. So you can see I wrote the word circumference there. So when you are rotating, a circle is formed. So this is a circle. So basically area of the base means area of the circle. So what is the area of a circle? Area of a circle is pi r squared, and your perpendicular height, well, that's h for height. Now this is the formula, so every time we work out volume, in this case it's just one graph, we will always be using the formula pi r squared times h. We do not need the formula sheet. It's a simple formula to remember. Pi r squared times h. Go to your diagram, identify what is r and what is h. Now let's go back to the diagram. Remember that we always have a choice when we are dealing with area. What do I mean? I mean, we could use this type of representative rectangle. There's your delta x, that's y1, y2. Or we could use this type of representative rectangle. There's your delta y, and that's x2, x1. That is, if we have a choice when we are working out area. However, when we are working out volume, we do not have a choice because we are restricted to just one method, which is this method. So therefore, our representative rectangle must always be perpendicular to the axis of rotation. What does that mean? It's a simple thing to do. Watch it. So which axis are we rotating about? We are rotating about the x-axis. So there's your x-axis. Right, so here's your x-axis. Now, if you want to draw a perpendicular representative rectangle, then there is a perpendicular. You draw a straight line coming down, and then that is perpendicular. Perpendicular means it intersects and forms an angle of 90 degrees. So can you see the longer side is perpendicular? The longer side is perpendicular. So if we are rotating about the x-axis, we must always use delta x. Let's do the other one. Here's the y-axis. This is the y-axis, which is a different example that we're dealing with. When we are rotating about the y-axis, it must still be perpendicular. So how do I draw a line that's perpendicular to this? There's a journey. There's a perpendicular line. So if you are rotating about the y-axis, you must use this type of representative rectangle. You can see the longer side is perpendicular, so there's your delta y. Alright, so that is a theory here. So in this case, I'm rotating about the x-axis. That means I must use a representative rectangle with a breadth of delta x. There's the journey. So here's my representative rectangle. Here's my delta x, and there's my y1, that is y2. Okay, always, top is y1, bottom y2, it's up to you. Or top y2, bottom y1. Right, now, what's touching the top, what's touching the bottom? Just like how we did area. Okay, so what's touching, this is the top. And this is the bottom. Okay, so what's touching the top is y1, what's touching the bottom is y2. So volume will always be worked out. Volume of the top graph minus volume of the bottom graph. In this case, well, the bottom is the x-axis, but it will not always be the x-axis. We will be dealing with graphs, two graphs where we have points of intersection. So when we write down our formula, we should write it down in a general form that covers both situations, where we have one graph or two graphs. Right, so now let's get to working out the volume. Let me erase what I have just erased this part so I have more space. You should be copying this down. Right, so I've just redrawn, it's the same diagram, so don't worry about that, it's the same diagram, I just redrew it, created more space for myself. Now, What do we know? Okay. We identified the area. You can see that this is the area here. Okay. So now the volume. Remember, what's touching the top is y1. What's touching the bottom, we call it y2. It happens to be the x-axis. It won't always be the case. Now the fact is we got delta x. Right, so now the disk method. Okay. So we know that delta x is perpendicular. Delta x is perpendicular to the x-axis. Alright. So the representative rectangle with a breadth of delta x is perpendicular to the x-axis. So therefore, disk method. Now, what is the disk method? I'm repeating what I just did now. Disk method is pi r squared h. That is the disk method. Area of base times perpendicular height. Now, what do we know? We know that our radius is in terms of y. Okay. So, what do I mean? That means from there to there, we got our radius, and this delta x will now be called the height. Okay, so your radius is in terms of y, your height is equal to delta x. Those are the two most important things you need to understand before you actually write down the formula. So now, compulsory step, delta Vx. Now what does this mean? That if I write down x, then this means axis of rotation or reference axis. Now, you check your diagram, top is y1, bottom is y2. There's a top y1, bottom y2. So the formula is going to be volume of the top graph minus volume of the bottom. Okay, volume of the top graph minus volume of the bottom graph. Even though there is no bottom graph, but we're taking the bottom graph as the x-axis to create a general situation for the disk method. So now, what is the volume of the top graph? What is your radius is in terms of y? So it's going to be, remember the formula is pi r squared h. So it's going to be pi, top graph is y1, so it's going to be y1 squared delta x, pi r squared h. There's your formula. So that is top graph minus bottom graph pi y2 squared delta x. It's the same height. You can see delta x, whether it's y1 or y2 here, delta x is delta x. Now simplify this. So you see pi and pi is common. Delta x is common. And what we take it out as a common factor. And now I got y1 squared minus y2 squared. Okay. Now, there's my delta Vx. So now this is the formula for the volume of just one representative rectangle rotating. Now we write down the total volume formula. So now I do not write down delta there, I'm just writing down V for volume, and then I put in my integration sign. As soon as I do that, you know what's going to happen. Delta x now becomes dx. We are now integrating with respect to x. dx means integrate with respect to x. We want the x value at the beginning, which we will call A, the x value at the end, which we call B, which you can see there. Pi is a constant. Always take your constant, your number, you know, multiply, write it in the front. So this is y1 squared minus y2 squared. Okay, now let's substitute. Okay, so you go to your diagram. This is the line, x is equal to 2, so we know this point here is 2, 0. This is the ending, and the beginning is 0, 0. So take note of the beginning and the end of the volume. So now I got my 0 and 2. Now you go to your diagram. What is y1? So you go to y1. There's y1 here. It's y1 is the straight line. It's touching the straight line. So y1 is 5x. But this is y1 squared. So it must be 5x squared minus y2. Go to y2. y2 is touching the x-axis. There's y2 touching the x-axis. So on the x-axis, y is 0. It won't always be 0 when we are dealing with two graphs. Okay. But here, this is the formula that deals with two graphs. It's just that we are taking y2 as 0. So basically what's happening now? We got pi there, 2, 0. Then I got 5x all squared. That's going to be 25. X squared, 0 is squared. No, 0 squared is 0. 0 times anything is 0. So this is out. All you're doing is squaring this. There's your dx. So all we need to do is integrate to 25 squared. So that's going to be equal to pi. And then we got 25x squared 2 plus 1 is 3 over 3. Substituting 2 and 0. And let's see what we get. So I got 25 over 3 multiplied by 8. 2 to the power 3 is 8. So I'm getting 66,66666 here. Minus, if I substitute 0, I'm getting 0. This is the recurring, remember that. So 66,66 recurring times pi is equal to 209.4395102. Round this off, it's 209,44 units to the power 3, because we are dealing with volume. Volume is units to the power 3. And that is the first example. Alright, our next question here. Show that the volume of the solid generated when the ellipse x squared over a squared plus y squared over b squared is equal to 1 rotates about the y-axis is given by. So basically we're given the solution, we need to prove. We need to show how we get to this here. So here is the standard equation for your ellipse. So here is it. Let's sketch this ellipse. Right, so your ellipse is an oval shape. So we know that this is A, a0, so x squared over a squared, a will be plus a minus a. Those are your x-intercepts. And b and minus b will be your y-intercept. So that's 0, b, 0, minus b. How did I get that? Okay, how did I look at it? So let me just show you. For x-intercepts, you let y equal to 0. So I go to the original equation, and then I'll go x squared over a squared plus. I'm replacing y with 0, so that 0 squared over b squared is equal to 1. So 0 squared is 0. 0 divided by anything is 0. So then I have x squared over a squared is equal to 1. I need to solve for x. So I will multiply by a squared on both sides. So x squared is equal to 1 times a squared, which is a squared. Now I need to solve for x. So I will find the square root of both sides. So I'm going square root there. Square root of x squared, square root of a squared. Remember, plus or minus. You have to, there's two possibilities. That's why you must put both signs whenever you're finding the square root. So that means x is equal to plus or minus. The square root of a squared is just a. So that's why we get plus a and we get minus a. But notice how I am labeling the x-axis. I don't just write down a and minus a. I'm labeling it as coordinates. On the x-axis, y is 0. So there's a plus a, there's a minus a. Now obviously I don't need to show you how to work out the y-intercepts. To work out the y-intercepts, let x equal to 0 and then it will work out just like how we did it. Alright, so now, what was the question? Show that the volume of the solid generated when the ellipse, this is the ellipse, x squared over a squared, let's label this x squared over a squared plus y squared over b squared is equal to 1, rotates about the y-axis. So, as I explained in the previous example, that when you are working out volume, you do not have a choice. There's only one method, which is adjustment. So it actually makes things a bit easier for you. All you do is you check, read the question, and look for the axis of rotation, the reference axis. So rotates about on the y-axis. That means now use delta y. Use the rectangle with delta y. So what do I mean? You draw your representative rectangle, there's it there. Right, so you draw a horizontal representative rectangle. Right, so there is your delta y. So what am I doing now? I know if this is delta y, that means let's call this x2, let's call that x1. Okay, now this graph is rotating about the y-axis. So basically what's happening here is we do not need the full graph. All we need is one half. It's either the right half, or if we block this out, we can use the left half. Why? Because when you are rotating, if you take this and rotate it, it's covering this side also. Or if you take this side and rotate it, it covers the other side. So we only need half. We take this part according to what I've labeled and rotate it. Now, let's write down, the most important thing is write down your statement that here's your y-axis, here's your y-axis there is your representative rectangle, and you can see it is perpendicular to the y-axis. That's your delta y, that's, what did I label that as? x2, x1. Okay, so we know that this delta y is perpendicular to the y. So that is the situation that we are dealing with. Perpendicular, so therefore, disk method. You will write this down every single time you do an example. Because when you come to N6, there's two different methods. You won't always be the disk method. That's why you need to understand what's happening with the disk method. So what is the disk method? We know volume is equal to pi r squared h. Area of base times perpendicular height. Your radius is measured in terms of x. Okay, so what's happening is you're going around and around the y-axis. So the radius is the distance from the center to the circumference. It's an x value. You can see that we're measuring an x value. So let's write this down. Delta V y. Delta V y. Where did I get this y from? From the question, that is axis of rotation. We know it's going to be volume of the top graph minus volume of the bottom graph. So it's going to be volume of the top minus volume of the bottom. Always. Whether it's one graph or two graphs, it's best to write it down this way. So volume of the top graph, that's going to be pi, your radius. So we're going right minus left. Now, if you are unfamiliar, you need to go back to area questions and have a look at how we're looking at the area. So I'm going right minus left. So that's pi. There's your radius on the right, and there's your radius on the left. Okay, so it's going to be pi x2 squared delta y. Okay, pi x r squared times h. So you know this here is the height and this is the radius. So it's going to be pi x2 squared delta y minus pi x1 squared delta y. Take out a common factor of pi and delta y, so I'm left with x2 squared minus x1 squared. Now I will write down the formula for total volume. As soon as I write down total volume, I know I'm putting in my integration sign, my integration symbol. Delta y becomes dy. We are integrating with respect to y. I got x2 squared minus x1 squared. This is going to be my d and c. d and c. dy. What do you remember? If we are integrating with respect to y, we want the highest point and the lowest point. Okay, so go to your diagram. So the highest point up is b, and the lowest point here is negative b. You can see that. We are interested in the y values because we are integrating with respect to y. Now, let's substitute. What's your d and c? So that c is minus b. That's the bottom there. And going to the top is b. What is x2 squared? Let's go to our diagram. x2. There's x2 here, there's x2 here. What is x2? Touching. It is touching the curve. So we need to make x the subject of the formula here. So let's do that. So we got x squared over a squared plus y squared over b squared is equal to 1. Okay. This we know is x2 because it's touching x2. So we need to make x2 the subject of the formula because I have x2 squared here. So now I got x2 squared over a squared is equal to 1 minus y squared over b squared. Now, x2 squared over a squared is equal to, find the LCD here. So that's going to be b squared minus y squared all over b squared. Now, multiply by a squared on both sides. So that's x2 squared is equal to, now multiply by a squared and a squared will cancel. So I got a squared multiplied by b squared minus y squared all divided by b squared. Find the LCD. Very important. Okay, especially when it comes to the integration. But always find your LCD. Now, x2 squared. There's x2 squared. The whole point here is to get x2 squared in terms of y, because we are integrating with respect to y. So x2 squared, let's substitute. My x2 squared is a squared over b squared, and that is b squared minus y squared. So that is my x2 squared minus x1 squared. Now, what is x1? x1 is touching the y-axis. There's x1. x1 is touching the y-axis, and on the y-axis, x is always 0. So that is out. Alright, now let's simplify first. So what do I want to do? This is out. 0 squared is 0, which is out. A squared over b squared is, or are numbers. Any number you have, take it, multiplied by pi in front. So that's going to be a squared over b squared multiplied by pi. And then I got b and minus b. And then I have b squared minus y squared dy. Now it's much easier to integrate this. So this is going to be equal to, we got a squared over b squared pi. Now I can integrate with respect to y. Integrate with respect to y. So this is going to be b squared, which is a number. Your b squared is a number. So if it was 10, it will be 10y. If it was 20, it will be 20y. So it's b squared will be b squared y. Remember, b squared represents a number. Minus integrate y squared, that will be y to the power 3 over 3. Substituting positive b and negative b. Alright. Now let's see what happens when we do the substitution. Alright, so now this is equal to a squared over b squared pi. So what am I going to do now? I'm going to substitute b in here. So when I substitute b here, b times b squared will give you b cubed minus b to the power 3 over 3. Alright, so let me just repeat what just happened there. I am substituting b in place of y. So b times b squared will be b cubed. B to the power 3 is b to the power 3. I substituted the upper limit, put down the minus sign, substitute the lower limit. So if I put minus b here, minus b times b squared is, slide this down, minus b times b squared is minus b to the power 3. Minus b to the power 3 is minus b cubed times the minus will give you a plus b cubed over 3. Okay, you can check that. What did I say? If I substitute a negative raised to an odd power is negative, so the result is a negative times a negative gave you the positive if you are wondering. Now, right, let's see what happens. I'm going to just work it out here. So I have a squared over b squared pi. And now I need to simplify. Right, so I need to simplify this. So here, I can work this. Let me just remove the brackets first. Let's see what happens here. So that's going to be b cubed minus b cubed over 3. Negative times negative, positive b cubed negative times positive, negative. B cubed over 3. That's all. Now, what can we do here? Okay, let's add them up. So I've got a squared over b squared pi. Now, I can find an LCD of 3. My LCD will be 3. Right. So what does that mean? I need to multiply by 3. So that's going to be 3b cubed minus b cubed plus multiply here by 3. 3b cubed and here by nothing. So that's minus b cubed. Let's see what happens now. So I've got 3 plus 3, which is 6, minus 1, which is 5, minus 1, which is 4. Oh, 3 minus 1 is 2. 2 plus 3 is 5. 5 minus 1, which is 4. So we got 4b cubed over 3. Let's multiply to get our final answer here. So therefore, b squared will cancel with b squared here. So b squared is out. So that's going to be a squared b. There's a 4 here too. So 4a squared b pi all divided by 3. Was that the solution? Where is it? There's it here. 4a squared b pi divided by 3. So we know that is correct. Right, so this is units to the power 3. So these are 2 introduction examples